So I just want to let everyone know we're going to be recording. So welcome to the introduction of the graduate program here at Lehigh's Electrical and Computer Engineering Department. I'm Professor Shalini Kishore. I'm one of the faculty members in the department, and we're very happy to have you joining us today and learning more about our department and our graduate programs here. At the meeting today, we have a number of faculty and student participants who have joined, as well as Jody Imler, who's our graduate coordinator, who some of you might already be in touch with. We have Professor Kazai, if you can just wave. Professor Kazai is joining us. Professor Wuji Wen is joining us. Our department chair, Professor Chensheng Zhao, is here, and Professor Yan, who's the director of our graduate program. I believe Professor Sushil Kumar will be joining as well in a little bit, but these are just some of our folks here from the department who are going to be talking about different aspects of the program. In addition, we have the good fortune of having a couple of our students and an alumni joining us. Alex Carr is a current master's student in the computer engineering program. And Zhen Fang is a Ph.D. PhD student in the electrical engineering program. In addition, Marta is joining us, who recently graduated with a master's degree from our department and is currently working at Tesla. So thank you everyone again, and thank you to everyone within the department and our students and alumni for helping us out today. So we're going to start out by giving you a general overview about Lehigh, our college, our department, our graduate program, and then we'll start with a Q&A with our current students and alumni, so the folks joining can ask some questions and learn more about the program through them. Then
no, we'll again.
Hello? Oh, okay. And then we'll do a little bit of a discussion of the research areas we have in our department, since many of the graduate students who join us participate in different aspects of research work for their dissertation or just for general coursework. And then we'll do a Q&A with the faculty to learn more about the research areas and the program in general. So starting out, first of all, I know some of you may not know a lot about Lehigh University, so we'll tell you that we're located in the northeast part of the United States. We're very close to a lot of the major metropolitan cities in the northeast. In fact, we're about 85 miles from New York City and only 57 miles from Philadelphia. Lots of large international airports that are nearby, as well as some of the larger cities along the eastern seaboard, as you see on the map here. We're located in the Lehigh Valley in Pennsylvania. Our campus is quite large. It's about 2,400 acres. It's a gorgeous campus, as you can see from the pictures. We're a top university with almost 5,000 undergraduate and over 2,000 graduate students. Our university is broken up into 5 different colleges. We've got the College of Arts and Sciences, College of Business, College of Education, our College of Engineering, and then there's a newly formed College of Health. Just to mention, I mean, as you see in the pictures here, Lehigh is a very beautiful campus. I just want to sort of mention that last week I was doing a tour with a parent who was here with a high school student looking at Lehigh, and the mom said this was the first college that she was visiting, and she just absolutely fell in love with it. It made her want to go back to college. It was so beautiful to see the campus. So. For those of you who can visit, we would love to have you visit in person, or please, check out our images online and get a feel for what the campus looks like. Our engineering college is the Rosen College of Engineering. We have 140 tenure track faculty across 8 academic departments, including our own. There's about 2,200 undergraduate and 850 graduate students. The College of Engineering is the research hub of the university in a lot of ways. More than half of our PhD graduates come from this college. More than half of our journal publications, our research expenditures are coming out of this college. As an example, some of the outstanding faculty we have here who do research, 30% of them have this very prestigious National Science Foundation Career Award, which is very difficult to get, and the 30% number is well above national averages for most universities. We're also above national averages for the number of women we have in our engineering student body, about 31% compared to a national average of 18%. Of course, we have work still to do to bring that number up, but we're proud of the fact that we're making progress there. Our department, Department of Electrical and Computer Engineering, is the main offices are located in Packard Lab, which is the image you see here. It's one of the oldest buildings on campus, and the electrical engineering program here at Lehigh is one of the oldest in the United States, dating back to the 1890s. By our estimate, maybe the second or third oldest in the country. There are 16 tenure track faculty members in our department and 1 professor of practice. Very distinguished faculty. We have 5 IEEE or Canadian Academy of Engineering Fellows. We have 7 NSF career winners, 1 Young Investigator Award winner, 1 PCASE winner, and 3 IEEE distinguished lecturers. The research areas are focus areas are distributed across photonics and circuits, signal processing and communications, electrical power and energy, computer engineering, and then bioelectronics. Across these different areas, we have about 160 undergraduate students and 60 graduate students. Altogether, our facilities and equipment are excellent. At the undergraduate level, we recently got a large donation to significantly upgrade some of our lab facilities, and at the graduate level, we have a lot more research facilities. There are excellent labs throughout. I believe someone has their speaker on. Maybe if you can mute it, we're hearing some. Thank you. Okay. I'm going to turn it over now to Professor Yan, who's the director of our graduate program, to talk about the graduate degrees in the ECE department.
Good morning, everyone. I see that actually Professor Kumar just joined us. Professor
Great.
Kumar, if you just wave at us. So yeah, okay, thank you. I'll just provide some brief information about our graduate programs. And of course, for more detailed information, you can always find these from our website. The department offers 7 graduate programs, and we are one of the 3 departments that offer a brand new data science, Master of Science in Data Science. So the graduate programs we offer fall into on 2 levels, Ph.D. and Masters. So we have Ph.D. programs in EE, electrical engineering, or computer engineering. To get a Ph.D. degree, typically you will need 72 credit hours after earned bachelor degree, or 48 credit hours after a master degree. We also have Master of Science degrees in electrical engineering, computer engineering, photonics, or data science. And these Master of Science programs will require 30 credit hours to graduate. And for Master of Science programs, you have the option to do 6 credit hours of thesis or independent study. And finally, we have Master of Engineering programs in electrical engineering or computer engineering. And these also require 30 credit hours to graduate. But for these, you do not have the option of thesis, but you do have the option of 6 credit hours of independent study. Next slide, please. So here are some dates and key facts of our graduate admission. And in order to be considered for financial support for PhD students, you have to complete your application by January 15th. For our master level programs, the application deadline is April 1st. And if you're might be a bit late already. If you're still thinking about spring admission, then deadline typically is November. So department actually recently decided to waive GRE for all our graduate programs applications. And finally, and the application fee may be waived. So I believe for all participants of today's webinar, I think you will receive application fee waiver. And please contact Jody after the webinar. And also you can, the English test score requirements for international students are also provided here. If you do not satisfy these requirements, you may be required to take some remedial English courses after you start at Lehigh. Next slide, please. So this is about financial support for you during your program. Typically in the, we do not offer financial support for master students. For PhD students, I would say most of them are supported during the entirety of their PhD programs. And the support comes in different forms, fellowships, research assistantships, teaching assistantships, and so on. Next slide. So here, actually, I provided a very busy table. This is actually lists the average Bachelor of Science starting salary provided by University Career Services for the past 3 years. I guess the point here I'm driving at is that computer engineering and electrical engineering actually have pretty much been among the most popular engineering disciplines in the college. You can see actually for the last 3 years, based on these numbers, computer engineering and electrical engineering are always among the top 3, when you compare all the engineering disciplines. Okay, so I just want to show you that, choosing computer engineering and electrical engineering after graduation, you have a great future, finding jobs and so on. Next slide. So speaking of jobs, so where do our, ECE alumni work, right? Typically, I think that mostly 3, kind of categories, major, corporation companies, leading tech companies. You can see Apple, Google, and, lots of a lot of major companies you may not necessarily associate with, ECE. So for instance, I think one of our panelists today is working for Tesla, right? And another possible places is being, employed by, research labs, for instance, Argonne National Lab and so on. And third category is also we have, PhD graduates, pursue academic career after graduation. So, okay, with that, I'll hand the baton to Jody.
Hello, I'm Jody Imler. I'm the graduate coordinator here in ECE. I know I've spoken with many of you, and as they said, I will follow up to after the webinar with anyone who needs an application fee waiver. Some of our popular questions from students in the past are regarding job opportunities for international students. So this slide explains the CPT program, which is the curricular practical training, which allows F1 students to work and get some experience while taking classes here at Lehigh. Most of the time it's done through the summer, but sometimes it is done in the spring or fall semester. And the OPT, the optional practical training, allows you to extend after you graduate to stay in the United States and get a position then. And I've been with this department for a year. I started last fall, and in that time, we've had 9 students participate in this program. So if it's something that you would be interested in doing, you would talk with your advisor, and then you'd reach out to our Office of OIS, Office of International Students and Scholars, and they will work with you to get the necessary paperwork set up. Next slide, please. Another one of the questions we often get are what countries are our students from? So this is just our ECE graduate students only. So as you can see, about 14% are US domestic students. The rest of them, 86%, are international students. The majority of our students are from China. We do have some from India, Iran, Mexico, and Bangladesh as well. Next slide, please. Regarding the demographics, we currently have about 60, well, exactly, we have 57 students. It's broken down about half and half in between our MS and MEng degree and 49% for our PhD degree. About 70% of those are in our electrical engineering major, and about 30% are in our computer engineering major. Regarding gender breakdown that Professor Kishore mentioned earlier in regards to Lehigh and the nationwide, currently we have 21% are females in the ECE grad department and 79% are males. Next slide, please. And a lot of people ask what grad life is like here at Lehigh. We do have a very active grad life program here at Lehigh. They offer a free breakfast every Tuesday. You're welcome to go to that in the, I think it's in May, April or May, they have Graduate Student Appreciation Week. It's a whole week devoted to grad students. You can see they have a welcome back picnic. They had a hiking excursion. Before, as a department, ECE, before COVID, we had a yearly graduate student dinner where faculty and staff and grad students would come together. And we're gonna be doing that again this winter, probably in January or February for our grad students. That's something that used to be done every year before COVID, and we're gonna be reinstituting that this year. Next slide, please. And as Professor Kishore mentioned earlier, it truly is a beautiful campus. We experience all the different seasons here at Lehigh, from snow to the beautiful leaves in fall and spring flowers and the cherry trees. Our library is the dome ceiling with a stained glass window. It's a very beautiful campus. And our next slide, we're going to do a Q&A with our alumni, Marta, and our two current students, Alex and Zen. And as you can see, Marta is an alumni, graduated in May, and she is working at Tesla. Alex is a Lehigh undergrad who stayed on for his Comp E degree here in MS. And Zen is a PhD student working on his electrical engineering degree. So you're welcome to ask them questions while they're here and logged on if there's anything you'd like to know. And later on at the end, there will be additional Q&A for faculty and staff and anything else you'd like to know. Thank you.
Maybe we can start it off. There's a question in the chat. Want to maybe look at that. If we have a GRE score, can I submit it? Moreover, do I require a PhD, a supervisor before applying for the PhD? I mean, these are not necessarily for the students, but I figured maybe it'll warm us up for questions.
Yes, I think that if you have a graduate score, it's not required, but we do not discourage people from submitting your GRE score, I think. So some advisors may use that as an additional data point. And about the second part, we would strongly encourage you to contact faculty members to identify a potential advisor, research advisor, and work with that person. You know, and because our admission, PhD admission process is very much faculty driven. So that's something you should really you're strongly encouraged to do.
Maybe in that regard, Zen, you can talk about your process of application and how you had reached out to faculty before. Zen?
Hi, can you hear me?
Yes, yeah. Maybe you can talk a little bit about how, when you had applied and what the process was for you to identify a supervisor and how you went about that.
Oh yeah, so for me, my case is a little bit of like particular. I'm start as a master student here in Lehigh in the 2017. So so during the first year of my master, I'm like looking for like I'm decided to go further for my like academic life. Like in the future, I decided to be a like PhD student. So I'm looking for like firstly, I found my like research interest and my background in the undergraduate and the master is more about the power system. So and my advisor Professor Wenxin Liu is like working on this area as well. So I just like appointed with him, talk about my like my plan and ask about him like what he's working on and tell him I'm really interested with what he's doing and we have a because I'm in Lehigh, he's in Lehigh, so we have a lot of chat after class or I go to appointment with his office hour. That's so I want to say so if you go to Lehigh as a Lehigh student, the faculty and the professors are very nice to offer like at least give you a chance to like as an interview learn about you and learn and I think so connect with like potential advisors is very necessary when you're going to be a PhD to see if they need you, if what they're doing is you're interested. And the following application is to fill in a lot of like the paperwork online. And I think our coordinators, they are very willing to helpful, give you the instructional about how to apply, which kind of score you need to submit it, which kind of like transcripts you need to submit it. So I think just ask people, that's very helpful.
Thanks, Anne.
Alex, would you like to introduce yourself and tell about your experiences here at Lehigh?
Yeah, sure. So hello, my name is Alex Carr, and I'm a master's student in computer engineering this year. And so I also did my undergrad degree in computer engineering at Lehigh as well. But I decided to stay for a master's degree specifically because Lehigh, because it's only a 30 credit program, it's a great opportunity to be able to complete it in 1 year, being able to take some courses over the summer as well as during in the fall and spring. So that was one of the major reasons why I decided to stay and get my master's degree. And overall, it's been a really great experience. Like Zen said, a lot of the professors in the department are very open and they're super easy. If you have questions or want to reach out, you can talk to them about either areas of interest, if you're interested in doing research, or also general questions that you have about courses and other things as well. So yeah, it's been a great experience, and I plan on graduating in the spring. So just getting my master's degree, but it's been a really cool experience and something that I definitely think was worth it for me after getting my bachelor's degree.
Thank you. And Marta, do you mind saying a couple words about your time here at Lehigh?
Sure. So I'm actually in the exact same boat as Alex. I was an undergrad in computer engineering and then went to continue my master's as well, both at Lehigh. And I did it mainly to solidify my knowledge base in my major. I wanted to go a bit deeper in certain directions. And I think that the difficulty of the coursework really provided that opportunity, as well as I fully agree with everything they've said about the faculty. The professors here are phenomenal. They've always been so open and are definitely probably one of the reasons that I benefited so much from these degrees that I got here. So I definitely think that going here was beyond worth it from my perspective.
Thank you. And the one other question we've had in the past as well is the class size in our graduate classes, and that can vary from anywhere from like 5 students to 19 students in one of our graduate level classes. So it does give you the opportunity to make that connection with faculty members when you are in their class, and you can always do office hours and make appointments as well, but that is something I know that students have asked in the past. Are there any other questions for the students as of now? Otherwise, we can go on with the research presentation. No? Okay.
So as a brief overview, we have research activities going on in a number of domains. Some of them are listed here. Bioelectronics, a lot of work in the data science space and machine learning and AI, cyber physical systems and communications, computer engineering, electric power and energy, and semiconductors and photonics. We have a number of our faculty joining us today who can speak to some of these areas. Some who couldn't join and wanted me to make sure that you knew that they were available for questions if you needed to learn more about that. So I'll go through a couple of them, or I'll go through this one, and then the faculty will go through their areas. This is the bioelectronic and biophotonics area. We have 3 faculty members who work in this space. Professor Berdichescu wanted to join today, but wasn't able to, and he wanted me to extend the invitation for all of you to reach out to him if you had any questions and in learning more about this area in particular. But this is a nice, very cutting edge domain in which our department is very active in. Next, I'm going to turn it over to Professor Kazai to talk about the electrical energy and power systems area.
Hello, everyone. Thank you, Dr. Kishore. Very nice meeting you. So I'm here representing the power group, some of the activities that we are doing here at Lehigh. So we have 2 labs specifically focused on power and energy area. The one on the bottom right is Dr. Wenxin Liu's lab, Smart Grid Laboratory. He has several cutting edge equipment, including real-time simulators, multi-level converters. He has assembled a DC microgrid in his lab. And most of his research is funded by the Department of Defense on several projects related to the Navy shipboard power system, and he is active in the area of control systems and its application to power system. The one on the bottom left is the Integrity Lab, which I manage. It's short for Integrated, Resilient, Intelligent Energy Systems. So I'm going to talk about some of the capabilities of our power system group here in these slides. But in my lab, you have also a real-time simulator and also a power hardware in the loop microgrid system. It's a 10 kilowatt microgrid, which allows us to test different control design optimization and also machine learning based research in power and energy field. Next slide, please. So this is one of the areas that we recently started looking into, and that's data-driven modeling. So on the figure, you see a structure of a power converter. So this is a structure of a distributed energy resource. It can be a solar energy conversion system, wind energy conversion system, or battery storage system that is connected to the electricity grid. Normally, this is done through a power converter, which converts a DC power to an AC. Or alternating current. And for us, since we have a lot of manufacturers developing these devices and we are integrating those to the power system, we are interested to see if we don't know anything about these components, how can we model those? Because without a model, there is no way that you can control devices. So one of the areas that we are active in is how can we take measurements from these devices that are running in the system, and using the measurements that we receive, we come up with the exact or accurate mathematical models for these systems. Once we have a good model or data-driven model, then we can design controllers that could basically predict future events, failures, and faults so that we can avoid those. So, and then we focus on different kinds of controllers for these devices, including linear controllers, nonlinear controllers, and advanced controllers based on machine learning. Next slide, please. So this is another area that we are, a couple of faculty members in the EC department are actively working on. That's the smart grid optimization. So in the smart grid, we have many resources that can generate power for us, including power plants. We have solar farms, we have wind farms. We also are integrating electric vehicles into buildings right now. So these resources are all available to be used for our demand, basically, or demand management. Now, this becomes an optimization problem. So there are several ways that we could solve these optimization problems. One of them is the numerical optimization. So our faculty work on developing these optimization methods, including Dr. Kishore, Dr. Parv, me, and also Dr. Liu. We are all active in this area. And then we have machine learning based optimization. That means instead of solving these numerical optimization methods, can we just utilize the data? And using the data that we have, and also the numerical optimization methods that are widely available using different benchmarks, can we train a machine learning to learn the solution and avoid solving these large scale complex problems? So this is the second area that we're working on. So this also includes demand management. So how do you design, for example, a demand management system that includes electric vehicles? How do you integrate electric vehicles into buildings? And we are all active in these areas as well. Another part of this smart grid optimization is cybersecurity. So we have so many devices connected to these systems, and we are all controlling some of those in our houses using, for example, cell phones. So these devices all communicate through wireless. Now somebody can get into these devices and hack into them and inject false data, for example, on the readings of these devices, or inject a false cyber attack on these. So cyber attacks are also categorized into optimization problems in power system. So we have several of our faculty members actively working on cybersecurity area, how to model cyber attacks. Once we model cyber attacks, the main purpose is to basically generate data. Once we generate data about cyber attacks, we can protect the system using different approaches, such as a state estimation or machine learning based approaches. So I know Dr. Kishore, Dr. Parv, and also Dr. Blom, and also I are working on these areas as well. Next slide, please. Next one is the control. So we are very active in designing controllers for distributed energy resources, or DERs, in power system, and several category of controllers can be applied. We have classical controllers, which require, for example, some knowledge about linear control that normally you obtain in the bachelor's or in the undergraduate studies. And then we apply some advanced control techniques, such as nonlinear controllers. We offer several courses in Lehigh so that you can learn about these nonlinear control techniques. And also we have distributed control techniques where you can basically communicate between the neighboring devices to control the whole system. And this is a peer-to-peer communication system. And also we have machine learning based control. As an example, Dr. Liu is working on reinforcement learning. How can we use machine learning to control devices? Or some of us work on model predictive controllers. How can we use basically model predictive control optimization techniques? Or how can we use deep learning to control the whole system? So these are some of the areas that we're active in the control system. Next slide, please. And this is basically the hardware in the loop setup. So HIL stands for hardware in the loop. So we have microgrid test beds that allow us basically to connect physical hardware to the system. And these physical hardware include, for example, if you have a small scale wind turbine in the lab, or if you have a battery energy storage system in the lab, you can directly connect it to the test bed. And then you can have a simulated environment using different software. We use MATLAB as an example to simulate large scale grids using OPAL-RT simulators. Once we have that, then we can design different controllers for this system. We can study how these devices or hardware-based distributed energy resources, or DERs, are interconnected to the grid and cause stability issues, or how can we control them in an optimized manner. So we have basically hands-on experience for all of our graduate students and PhD students so that they can work with these devices, obtain the knowledge that they need so that once they join the workforce, they have the required knowledge to do so. So these are some of the areas that we're active in the power and energy area. So I would be happy to answer your question, any questions that you might have at the end.
Thank you. So the next area is computer engineering. Professor Wuji Wu. Wen will speak about this.
Yes. Hello, everyone. So my name is Wen. So I'm currently an assistant professor in the department. I'm also a core member for the computer engineering program. So before I introduce the the details about the teaching and the research activities in the computer engineering, So I want to answer, one frequently asked question about, what is the role of the computer engineering? What's the difference between computer engineering and the computer science? So, in a very short word, so computer engineering, essentially, the goal is trying to design the future, the better computing hardware and the system for the future. So basically, you can consider that we are going to develop the better, let's say, energy efficient hardware like AI accelerators, right? And also computer architecture, for, let's say, GPUs and the microprocessors, and also very recently, like open source RISC-V. And also you can consider that we are also going to design like smaller devices, like, for the applications like Internet of Things and those things. So basically, this is a hot area which sits between the electrical engineering and computer science. So computer science is mostly focused on programming with hardware, but in computer engineering, so what we require is that students should know both software and hardware. So basically, that's also you can see from the definition. So our students, graduate students and non-graduates, they have very a lot of like job opportunities. So they can work in like the hardware companies like Apple, Intel, and also they can also work in software companies like Google or Meta, those Amazon, those. So basically, this is a hot area. So in terms of the teaching, we actually offer very unique courses. So our course covers from the, let's say, the very hardware aspect, like the digital system design, to help you to learn the industry standard, like how to design the semiconductor chips or very large integrated circuits. And also we have courses cover on the computer architecture, which is the foundation of many, computing systems. And also we have courses on the embedded system and the Internet of Things. And also we have courses like software, hardware co-design of the deep learning system, which offers a very different aspect, from the people talking in the computer science. It's more practical. And also we have courses on the GPU programming, so which are all very, very attractive. And also in addition, we also require students to have the knowledge about the software programming. So some courses like computer science courses like operating system algorithm are required in our program. So basically you can see that you can learn not only just the hardware aspect, you also learn the software aspect. So in terms of research, so I want to give a very quick overview about what we are doing here. So let me introduce Professor Kachir. He is a teaching faculty in computer engineering. He teach a lot of computer core course, engineering core course like Introduction to Computer Engineering, Embedded System, and many others. And Professor Gore is a core member in the computer architecture. So he is mostly working on the, the how to build more efficient memory systems. So including the emerging non-volatile memory. And also she is working on the how to leverage, the sparsity to accelerate the new applications like, the AI accelerator, all those things. So my group is mostly working on the electronic design automation and also the hardware acceleration for the future, applications like, neuromorphic computing, and also the domains, other applications like graphic analytics. And we are trying to design like more energy efficient, robust, computing systems. And in addition, we are also working on the hardware security, right now. So if you learn about Intel's Spectra and mile down those problems, you can see that hardware security essentially plays a very important role in the future, computing systems. And also we are working on some new domains, like how to do the software hardware design for the secure and private machine learning systems, and as well as some applications in the medical domain. So there are many interesting research projects ongoing. And also Professor Jen actually, she is working on mostly on the underwater communication, but she is also working on many on the robotics and Internet of Things, and also using hardware, to build more energy efficient system. I think Professor Yan is here, so I think Professor Yan can introduce a little bit about his research. So, Professor Yan.
Thank you, Ujie. Yeah, so currently I think I have two ongoing projects, just to give you a sense at what were my research. One project is actually collaborating with Professor Wen, and we're working on reliability and robustness issues in deep learning, deep neural networks. The other project actually is in collaboration with BioE, faculty members, and we're working on actually living neural network. We're trying to build actually networks using in vitro actually neurons, and it's a very exciting lot of challenges, actually interdisciplinary challenges and so on. Very exciting research. So just to give you some sense of my research areas, I think that's it.
Okay, so yeah, I think we also show some cool pictures, in the right side. You can see that the top one essentially is a picture from our group. So you can see that there are, cool like GPU, servers inside. So we actually running a lot of how to build energy efficient machine learning system using the powerful GPUs. And also we have the, computer hardware like FPGAs, those things, not only just software, we are also going to develop better hardware. And also Professor Janet is showing, a good picture, on the, on her research on the water, communication systems. And there is another picture, from Professor Guo's group, which is very, diverse and, have a lot of group activity. So overall, so computer engineering actually provides you, a very broad view about the future, what future computing system is, and it is a foundation for many, computer science and also other applications. It's an exciting area that you should definitely, you want to learn software and hardware, so come to join us if you have any questions. So feel free to let us know. Yeah, thank you. Yeah.
Thank you. I guess the next area, I think I may have missed one here. Sorry. Yeah. The next area is the communications and signal processing area, and I can speak about it. Professor Zhao's on the call as well, and he maybe can talk a little bit about the area as well. Broadly speaking, we offer courses in communication theory, networks, signal processing, information theory, robust set of courses. A number of our faculty also support the master's in the data science, the new master's program that we mentioned earlier. The research that we do is to apply those theories to traditional communication systems like cellular networks, 5G, and I guess upcoming 6G standards, radar communications, sensor networks, underwater communications, as Professor Wen just mentioned. So traditional communication networks, but also looking at more complex cyber physical systems, the use of communication and signal processing in larger systems like smart energy systems and power grids, like Professor Kazai mentioned, or in smart city applications, or intelligent automated transportation systems or robotics. So these are all different domains in which communication and signal processing techniques come into play. And oftentimes our faculty, when they're working in these different types of applications, they collaborate with domain experts from different disciplines. There's a lot of the research is very data driven. So as I mentioned, we do support the master's in data science, but a lot of our research problems are focused on different types of machine learning and AI type of topics. I think Professor Kazai mentioned a number of our faculty are also looking at at cybersecurity as a major topic theme that this area focuses in on. So it's physical cybersecurity, which addresses how to protect modern larger scale engineered systems from more complex cyber attacks than traditional network intrusion or denial of service type of attacks. We also have a number of our faculty working in interdisciplinary research efforts. As I mentioned, sometimes you have to work in different domains like transportation systems or energy systems and so on. All across our department, our faculty also collaborate with others in other departments, and we have research institutes that facilitate that. Lehigh started 3 research institutes, one focused on data science called IDIS, one focused on cyber physical infrastructure and energy systems called ICPI, and one focused on materials and devices called IFMD. All 3 of these institutes help faculty connect with other faculty in different departments and go after larger team projects. And a number of our graduate students participate in those types of interdisciplinary efforts. So I wanted to mention all of that. Professor Zhao, do you want to mention anything additional?
Yeah, I think you covered most of it. Hi, everyone. I'm Qin Xiao. We have a very strong team actually in this communication and the signal processing area. And we are doing very contemporary research topics from wireless to smart grid and cybersecurity and for information theory to almost cover a lot of hot topics. Thanks.
Thanks. Okay, so the next area, Professor Kumar can talk about the electronics and photonics space.
Hi, everyone. So I'm Sushil Kumar, and I'm an associate professor, and I do research in semiconductors and photonics. So you can call it electronics and photonics, but I'm going to talk about semiconductors and photonics in general here. So I'll talk about 3 things. First, maybe start off with the courses we offer in this area. And then I'll talk about the faculty in the department, what they do. And then also finally about the interdisciplinary kind of nature of this area. And because we have a strong presence throughout the College of Engineering and also in actually College of Arts and Sciences that touch this area. So right now, actually, we are on the smaller side of faculty size in this area due to several retirements, but we will have new faculty joining in January. 1 faculty member is joining. I'll talk about that a little bit, and then we hope to again build up strength in this area in the coming year or 2 and hire more. So right now, as of now, even with the faculty that you see on your screen, we are offering graduate courses. So the graduate courses are 400 level courses. Those are in advanced electromagnetics, fundamentals of photonics, where we actually cover laser theory, including all aspects of photonics and optoelectronics technology and devices. Then we have a course on physics of semiconductor devices. And then we used to have, and we plan to still offer, start offering again a course on applied quantum engineering, which is the quantum mechanics for engineers, as opposed to that offered in physics department. So these are the current graduate level courses. And then we also have some 300 level courses, which actually can be, some of them can be counted towards MS and PhD degree. For MS degree, for example, we have Introduction to VLSI Circuits, 361, 308, Physics and Model of Electronic Devices, and 322, Introduction to Photovoltaic Energy and Systems. So even right now, as of now, we have a relatively good coverage of courses in this area in both semiconductors and photonics. Next, let me just talk about my own research, and you're seeing 3 faculty members here. I do research in semiconductor lasers, but these are kind of non-traditional lasers. These are lasers that emit in the terahertz frequency range of the electromagnetic spectrum. Terahertz is, for example, 1 terahertz is 1000 gigahertz. So it's quite high frequency from an electronic standpoint. But if from a photonic standpoint, when you talk about visible light or infrared light, terahertz wavelength is actually very, very long in the sense, so it's, or a frequency is very small. So I don't know if you can make a connection, but it's kind of in the middle of what electronics people can do and what photonics people can do in terms of the frequency. So this is kind of like an underdeveloped region of electromagnetic spectrum. We use semiconductor technology, actually fairly advanced type of devices we build. We collaborate with Sandia National Labs to have these structures grown. You on the right of your screen, you're seeing kind of a band diagram. That's a typical way to describe the design principle of this. If you have taken any semiconductor courses, these devices that we build, these semiconductor lasers, are called quantum cascade lasers. They were first developed in Bell Labs in the 1990s. They are based on quantum wells, basically layers of gallium arsenide, aluminum gallium arsenide grown over and over again. And we design them, and then once we receive a wafer that's grown by our collaborators, we receive that and we do all the laser development, which is the processing of these devices in our own in-house nanofabrication facilities at Lehigh. And then all the experiments we do in my lab are at low temperatures, cryogenic temperatures. So we have to cool them down to about 70 Kelvin. So all of that is done in my lab. So I have primarily right now, I have 2 to 3 research directions. One is just to make more powerful lasers. So we have actually we have the highest power laser in the world for even today, as of today, for this kind of a laser. We are trying to increase power more. I mean, they have lots of properties that need to be improved before these are not yet commercial. So that's where we are going for. And then we are also trying to do develop spectroscopy techniques to be able to analyze chemicals, because terahertz light, one of the applications is in analysis, biomolecular analysis of various chemicals, pharmaceutical compounds, and things like that. So that's my own research. You are seeing on the right Professor Milt Hatlis. He has a display research lab. He was more active earlier. He used to build devices which can be on a flexible substrate, these electronic transistors, and also display devices. He is now more active in teaching courses like photovoltaic systems and VLSI circuits, and also the semiconductor courses that we offer to the undergrads. But he also advises graduate students. Professor Kafafi is an adjunct faculty here. She doesn't really do research at Lehigh, but she has guided Ph.D. students in the past, co-guided students. Her research expertise is, so she's been a scientist, a distinguished scientist at Navy Research Lab and also at National Science Foundation. And her expertise is in nano photonics, plasmonics, organic materials, organic devices. So these are the current faculty in this area, but we will have Dr. Ning Lee coming from IBM. He has had a long career at IBM. I believe he has more than 50 awards for his inventions there. So he's a research staff member there. And he will be joining us in January of next year, just in a couple of months. And he works on novel in-phase memory devices, neuromorphic computing, organic LEDs. So on the experimental side, high-speed photo detectors for optical communications, and actually other stuff also, for example, nitride-based devices. So we will have a strong research presence in the semiconductor photonics area, relatively broad, even with just these faculty members. So this is the research aspect and the courses that we offer within our own department. But photonics has been a very strong semiconductors and photonics has been a strong component at Lehigh in engineering in general. We have faculty in material science and physics. So in fact, we have this MS in Photonics program, which is jointly offered through material science, physics, and ECE department. So any student who wants to apply to that program can actually apply either in ECE or material science or physics. And there is a list of courses you can take from these departments. For example, the courses are from ECE I already mentioned to you, but then there are courses from physics such as nonlinear optics. And then there are courses in material science, for example, optical properties of materials. And there are more that you can take a mix of those courses to get an MS degree in photonics through either of these departments. We have faculty who work in even from, so apart from material science, we have faculty who do optical materials, atomic layer deposition, and towards these kind of novel semiconductor devices, 2D materials. In physics, we have people working on single photonic devices, nanophotonics, and we have even people in chemistry and biology who touch aspects of photonics. For example, people do spectroscopy in chemistry. So we have a strong presence. If you want to, if you remember, you can look up something called IFMD, Institute of Functional Materials and Devices. If you remember at Lehigh, there you will find a list of people who come together and kind of are addressing functional materials and device aspects of research at Lehigh, and you'll find more description of what people do. We have very strong fabrication facilities. So there are two aspects to the experimental capabilities at Lehigh. One is the material characterization aspect, one is the nanofabrication. So you'll find more information on the web page for IFMD. So we have a fairly good clean room, although it's not very big, but we have traditional aspects of all aspects of fabrication capabilities for such devices here. We have a very big electron microscopy facility and material characterization in material science department. You can read all about it. So in general, it's a very rich experience. If you join this area, we have had students, mostly graduate students after their PhD, who have actually absolutely no trouble finding a job. In fact, my graduate students have joined Apple, Facebook, on the photonics side of things. Even I think one student joined the Google, the self-driving car, the Waymo company, I think, and some semiconductor photon lasers, LED companies, the solid state lighting. So it's fairly easy because photonics is actually up and coming area. It's a technology.
Sushil, so maybe we can wrap up so students have a chance to ask questions.
Okay, yes. So yes, you can email me, sushil@lehigh.edu, if you have more questions. Thank you.
Thanks everyone. I know we're at the 9 o'clock hour now, past it. Some of us can stay on for a bit more. So if students have questions, please feel free to ask or to put it in the chat. If you have to leave because of time constraints, please feel free to email us afterwards as well. Okay, I guess we're out of time, so people might be interested in dropping off. Like I said, feel free to email us. We're happy to answer questions. We look forward to hopefully you applying and being here at Lehigh's campus sometime soon. Thank you again for your time today.